How you doing?
Alright.
We just scheduled finalized yesterday, so I wasn't able to make it in the other time.
Same situation, yeah.
Okay.
Yes, sir.
Alright.
We
Just
want to
had
let you know.
Alright.
Appreciate it.
Let's sign the roll today. So the roll's still going around? The roll? Who has the roll? Alright, so we spoke on last time about scientific notation. So we are going to revisit that discussion. Okay? So let me just pull up what I have here. It's not primary. Yeah. Make sure you circulate the roll. Don't hold on to it. Oh shit. Close. Why is it doing that? Let's see this. Accept, I'm sorry. Alright. Alright, so alright, so as I mentioned to you on last time, alright, the alright, so yeah, so like I mentioned to you on last time, All right. There we go. So yeah, so scientific notation. The reason why we do scientific notation is because we deal with very large numbers and very small numbers. Okay? All right? And so there are some rules for scientific notation, and we briefly discussed those on yesterday or Wednesday, right? That's what we said, right? Number must be between 1 and 10 or 9.9. Okay? Right? Then it has a multiple of 10, power of 10, and I'm going to put these slides up on the Canvas page, and you can download them if you want them. All right? And so this just shows you an example of a word of a incorrect number, or a number written incorrectly in scientific notation, right? And we know that the reason why it's incorrect is because of this, right? That number must be between 1 and 10, right? Or 9.9. All right, so quick little example again, right? So we want this number. This is the number, right? This is the actual number, right? And it has 6 zeros, right? So depending on, like we said last time, depending on who you are, right? Some people may see 7 zeros. Some people may see 5 zeros. So in order to avoid that confusion, we write it in scientific notation. And we just follow those rules that we just talked about. And we write this number, right? The decimal point is understood to be at the end of the number, right? And so we just move that until we get a number in between 1 and 10. And then however many spots that we moved it, that's the exponent of the 10, right? Okay. All right, so somebody want to tell me what this is right here in scientific notation? Huh? 3.47 times 10 to the 5th, right? How about this? All right, and right here, 6.14 times 10 to the what? 4. Good. All right. All right. Now we go back in the opposite direction, right? 1 times 1.23 times 10 to the minus 5. So what does this mean? Okay, so what does it mean? So what would this number be written out in the standard form? 0.0000123. You only had 3 zeros, huh? You should have 4 zeros, right? So if it's negative, you need 4 zeros in front of the 1. Got that? Same difference here, right? See, 4 zeros, right? Whatever the exponent is, 5, we need 4 zeros. We need 1 less than that. Well, you know, this is negative 5, but you know what I'm saying. The absolute value of the exponent, right? Absolute. Everybody know what the absolute value means? What does that mean? Yeah, the absolute value means it's not negative or it's always positive, right? We take the positive value. So when I say the absolute value of negative 5, I mean 5, right? So if the exponent is 5, right? Then, and it's negative 5, I know I'm going this way to the left because it's negative. It's getting what? Smaller. Is everybody following this? If somebody doesn't understand, they need to say, hey, I don't understand. And don't just sit there and let us run through this, and then we get to test day and we don't understand. Okay? All right. So, pretty straightforward though, right? All right, we don't need to try no more of those. Y'all pretty good. All right? So we'll keep it pushing. All right, whatever. That's just something else, okay. So, write this in standard form. We just did all of that. All right, so this is, I guess this is useful for us to know, right? And this is what I was saying on yesterday, that, everybody's not, everybody doesn't have the same background, so we must be sensitive to that, and we must spell out everything, right? So this is where we get the times 10 to the 4, times 10 to the 3, right? That's why we get that number. So 10 to the 8 means what? We have 1 and what? 8 zeros. Okay? 8 zeros. That's what that means. Right? 10 to the 1 has 1 0. Yeah. Anything to the 0 power is what? 1 itself. Or well, not itself, but 1. So you multiply it times 10 to the 0, it's itself. But it's 1. 10 to the 0 is 1. Anything raised to the 0 power is 1. Okay. All right. And so this is the opposite of that, right? This is so this way is going to the what? Going to the right. This is when we move in the decimal point this way. Right? This is when we go to the left. So when we go to the left, we're not multiplying by 10, we're dividing by 10s now. Right? And so that's why we see the decimal spot go in the opposite direction. Okay? And so this is what they're doing right here. They're just showing you where those come from. Okay? And we had enough of that, so we can keep moving. All right. And so this is what I was telling you, right? So, when most people think about physics, they're thinking about astronomy or astrophysics, right? Planets, comets, stars, galaxies, black holes, those things like that. Those are big things, okay? But there's also an area of physics which deals with very, very, very small things. Matter of fact, the smallest things that's known to mankind, right? Which are like what they call quarks, stuff like that, right? But those are subatomic particles. So even much smaller than this, okay? But this is what? Human cell, right? The nucleus of a human cell, okay? So a skin cell or something like that, whatever. The nucleus of that cell is these many meters, okay? So that's a 0.000007 meters. That's how big that the nucleus of a human cell is. Okay? Now, like I said, we go down much further than that in nuclear physics, right? Because we're talking about subatomic particles, like the particles that cause the atom bomb and stuff like that. All right? So they go down even smaller than that. All right? But that's just to give you an idea of the breadth of what we're talking about, right? We're talking about planets all the way down to the human cell or the nucleus of the human cell. Okay? Uh, ribosome. That's also in the nucleus. Something like some type of component of a cell. All right. It's also pretty small, right? All right. And so like I said, I'm gonna load those on the thing for you on the where's my unit? Oh, here. Let's see. All right, let's go get it again. No problem. And so outside of when we start talking about the actual curriculum, right? And I start using oh, that's too, that might be too elementary for us. Hold on. So this is what I do, folks. So you could do this too. All right. So if it's something you don't understand, you ask Mr. Google Man. Okay. That's your first resource. Let's do this. Add slides at the end of it. See what we get. I think this is no, that ain't it. I thought I saved it before I came, but I didn't. Oh, is it here? No. Alright, I'm trying to find you some slides. I don't want to just write on the board. Converting metric units. There we go. Oh. What the hell is this? Alright, well, we can use this. Alright. So we talked about scientific notation, right? Big and really big numbers and really small numbers, right? So the next topic we must cover, right? Before we jump into talking about physical science, is we need to talk about conversions, unit conversions, okay? Converting one unit to another unit, all right? So in science, everything has a unit on it, all right? If it doesn't have a unit on it, then it's just mathematics, right? So whenever you write a number on your exam, if you don't write a unit behind it, if you don't say 6 oranges or 6 apples, right? If you just write 6, then that's an incomplete answer. Okay? We must have units. Otherwise, none of this makes sense. This is the bedrock of everything we're doing. So this is very important for you to understand. That's why I'm saying it to you like that. All right? So you must understand how we convert one unit to another unit. All right? So, what are some units of measure? Right? Because in science, that's what we do. We make measurements. We measure things. We measure things and then we compare them to other things. Okay? So, what are some units of measurement? All right? First one we're going to deal with is length. Right? We have some examples of length measurements. Right? Meters, centimeters, kilometers. Okay? Then what type of units are those? What do we call those units? Metric. Those are metric units. Okay. Give me some English units of length. Feet. Right? Feet, inch. Pound is a unit of what?
Weight.
Weight. All right? Or mass. Okay? But an English unit of length is a foot or feet, inches, right? Miles, yards. Those are English units. That's what we learned coming up, right? What the rest of the world uses is this. And why y'all think the rest of the world uses this instead of the English system? Huh? Say it up. Speak up. Speak up. It's easier to convert. Absolutely. Absolutely. Right? And because the Queen of England owns the United States. So that's why we use the English system. If y'all didn't know that. All right? And everybody else uses metric. So, let's give y'all a little history lesson. All right? So, the Queen of England says, y'all gonna use this, and I said so, and it is what it is. But she dead now. So we got mass, right? So mass is grams, kilograms. I've never heard of that. Ton. I've never heard of that. All right, so we're going to be in grams or kilograms, right? So give me some English units of mass or weight. Pounds, right? Or what? Ounces, right? All right, and the last one here is capacity, and that's just like volume, right? And so normally when you go to the store and you buy a little drink or something, you're gonna get, your little 12, we say 12 ounce, but it's also what, 350 milliliters, okay? Right, so we have milliliter, centiliter, and a liter. So that's units of liquid volume, okay? And so of course they have all which measurement use weight each. All right, so what they're trying to show you here is that, right, different units have different units are used and applied to different objects, right? If I asked you, okay, well, what's the distance from here to New Orleans? You're not going to tell me that distance in centimeters. You can tell me in centimeters, but it's not going to register with me the same way it would if you tell me in miles, which is what we are accustomed to, because we drive in our car and we ride at 60 miles an hour, okay? So, different things, right? Even though we might be measuring length on both of them, we might use a different unit of measurement, okay? Same is true for weight, right? So, a human being is measured in what? Pounds, right? Or, we could convert pounds to probably kilograms, right? I don't know what the conversion factor is, but we can convert it. But yeah, we're talking pounds, right? But you're not gonna, if I ask you, well, what's the weight of your truck, right? A lot of times you're not gonna tell me in pounds, you're gonna tell me in what? Tons. You know what I'm saying? I got a 2 ton. I got a 4 ton, right? Even though tons can be converted to pounds, all right? So it's different units of measurement that can measure the same thing, but they're different scales. Okay? And so on and so forth. Same is true for, bottle of shampoo versus your swimming pool. All right. All right. So this is what's important. This is what we have to get. And we're gonna disregard that. All right. But so actually, I'm gonna give you a better chart than this. I'm waiting on the university to get everything settled with your mastering, I think. Any of your other classes you got the mastering yet? No? Yes? No? Okay, well I think it's a university problem. All right? So yeah, I'm gonna give you a better chart than this, but let's just use this one for now, right? And so here we could see, right, that that there's a relationship between these prefixes, okay? Right, now we just know the English units because they were banged in our heads from K through 12, right? 12 inches in a foot, 5,280 feet in what? 1 mile. 1 mile has 5,280 feet. Has 1,760 yards. Right? 1 inch has 2.54 centimeters. What's significant about that unit conversion? Anybody? I just said 1 inch is equal to 2.54 centimeters. So what did I do? Huh? Nobody? Okay. 1 inch is in what unit system? The English. 2.5 centimeters is in what unit system? Metric. So we went from English to metric and vice versa. Okay? So, and once we start doing some conversions, which we'll probably start next week, right? You're going to have to commit that to memory because we're going to use that quite often. Because that's how you're going to go from metric to English and English to metric, back and forth. 1 inch is 2.54 centimeters, right? All right, but if we go back to this chart, then all right. So I'm just gonna let y'all know though. So like, after so long, I'm gonna just collect the roll and then I'm gonna keep it, right? So if you show up at like 30 minutes after, then you just gonna be marked absent that day. All right. All right. So yeah. So we got 1 meter is 100 centimeters. All right. Centi. So what does centi mean? What does it represent? 100. Centi represents 100. Right? What does kilo represent? 1,000. Yes. All right. And deci? Deci? 10. Or, depending on which way you're going, 0.1. Right? centi is 0.01, deci is 0.1, and kilo is 0.001, right? So again, we're going off of, when we go in the left direction, right, we have one less number of zeros than the exponent, the absolute value of the exponent. So 10 to the minus 5 is 0.0000. 4 zeros, then 1. All right? And so, so here, again, right? And we got milli, right? Milli is what? What is milli? Milli is 1,000, right? Kilo is 1,000. Milli is 1,000. That's in the opposite direction. We following that? So we have, so we got kilo, right? Kilo, right? Hecto, deco, or deca, right? Then you have the actual unit. Then you have what? Deci, centi, milli. We have to commit these, right? At least for this class, y'all. I know y'all not science people, but for this class, we got to commit that for at least the next 2-3 months. Okay? All right. Well, we'll get some practice and you'll get a chance to work on it. Okay? So this is just an illustration of showing you, right? So if I'm going from centi to milli, then I do what? Multiply by 10. But if I'm going from milli to centi, I do what? Divide by 10. Okay? So that's important to understand. We have to understand which one is bigger. That's why you have to commit those to memory. Right? Because if I ask you, I say, well, how many millimeters are there in a kilometer? If you don't know that a kilometer is bigger than a millimeter, then you might have some problems with that. Or I might say, well, how many kilometers are in 10 millimeters? Is that possible? Yeah. Right? Yeah. Because in 10 millimeters, I have a certain number of kilometers. It's a small number, but they're there. Right? It's a matter of changing, again, the scale and the unit. So we got to understand which one is bigger, okay, and which one is smaller. That's the first step. Then we can make proper conversions once we understand which one is bigger, which one is smaller. And we do that by committing those prefixes to memory. That's the only way to do it. Okay? Where we at? 11:30? All right. So, what else? All right, we don't need to do none of these. What's this? All right, so this is some book that they got for this session. All right, so that's good enough. All right, so again, I can share this with you, all right? So let's get on the whiteboard now. All right. I need more lights in here, or is this the only light? All right. So let's do a unit conversion real quick. All right. So let's see. So I'm 6 feet. 6 feet 1 inch. That's my height. All right. Let's convert that. Let's convert that to centimeters. Somebody can help me out?
6 times 12.
Huh?
6 times 12 plus 1 times 2.4.
Okay. Right. So hold up. So let's start off a little slower. Right? So what's the first step?
To convert feet into inches.
Do what?
To convert feet into inches.
Yeah, we could do that, right? We converted feet. So she said what? We did what? We convert feet to inches. And why we did that? Right, so it's simpler because we can, well, it's mandatory actually because, right, in order for us to convert it, we have to put it all in one unit, right? So we converted the feet into inches, right? And we did that by doing what? So 6 feet, right? I just did what? I did that, so I said what? 1 foot is what? 12 inches. Right? And so what happens here is what? These two cancel out. And here we have what? 72 inches. Okay? And then we added the 1, right? 1 inch. Then we get what? 73 inches. Right? So this little thing right here is called a T-chart. And that's what we're going to be working on right here. Okay? Because I just gave you a relatively simple conversion. It's 1 step, 2 steps. All right? But when we get off into later chapters, we're going to have much more complicated conversions, right? So now we got 73 inches, right? Now we could do our T-chart again. This is called a T-chart. T-chart. Or a train track, right? So train track. Kind of looks like a train, right? Or a train track. This one's like I say, this one's short. So it doesn't look very long, but you're gonna have some that's gonna go way out here. Okay, 1 inch, and we said that was what? 1 inch is what? 2.54 centimeters. So again, my number cancels right here, and I'm left with what? Centimeters. Okay, this is a T-chart or a train track. I ain't got no. Oh, I tell you. Maybe that's what that's for. Right? So yeah. So then we'll hear. So that's another thing. I need y'all to start bringing your calculators. Okay? And not your calculator on your phone. You're not gonna be able to use your calculator on your phone. So you need a calculator. All right? So somebody tell me what that number is. $185 point what? 42. So 185.42 what? Centimeters. If I left the centimeters off, that's wrong. Most definitely wrong. All right. So this is called a train track, right? What's time? How much time we got? 37. All right. So yeah. So that's a relatively short one. So, but what if we did this? What if we said, let's do 6 miles. 6 miles to centimeters. Hopefully y'all got that. What's the first step? Go to feet. I agree. How we go to feet? Huh? How do we get feet from here? From 6 miles. Huh? 5,280. So I start off my train track with the number I'm trying to convert, right? Write it out. Boom. 6 miles, right? That's my little track across the thing, right? 1 mile is 5,280 feet. Right? I'll draw another track. And these two cancel. So now I'm at feet. Now what? Go to inches. 1 foot is 12 inches. These two cancel. Now I'm at inches. Now what? We at inches.
But how the feet cancel? If it's both feet, it is.
You say how they cancel?
Yeah.
This is diagonal from each other. You understand that? I'm not sure you do. I know. I could look at you and tell just by how you responded. You know what I'm saying? So, let me see how I can explain it. So, let's see. How can we explain that? Just give me a second right there. But hold on, let's keep going. All right. So 1 inch is what? 1 inch is what? 2.54 centimeters. Inch. Right? So now I'm at what? Centimeters, which is where I was trying to get. So then I'm gonna do what? 6 times 5,280 times 12 times 2.54. That's gonna give me my number. That's gonna tell me how many centimeters I have in 6 miles. What's the number?
165,606.40.
Scientific notation. Somewhere on your calculator, there's a thing called mode, and you can change it to scientific notation on your calculator. So your answer it comes out in scientific notation. So if you got a scientific calculator. Said 1 what? I'm gonna call you right back. I'm gonna play. All right. Anybody? Go ahead. Oh, I don't know. I don't know what. I have no idea what the number is. Right. That's why I'm asking y'all. So we're gonna so that's the last. That's what we're gonna wrap up on. Right. That's the last lesson. Is that in order for this to all make sense, everybody must agree. Right. Just like everybody in here agrees that $1 is $1. If somebody in here didn't agree with $1 being $1, right? Or if somebody in here didn't agree with, let's stick with that, $1 being $1, then, if this were an economy, then we'd be screwed, right? So we all have to agree on a correct answer.
So do you want us to give us the number that you got off the calculator?
Sure.
See how can you convert that?
No, the number you get off of the calculator, you can set your calculator to where it gives you the number in scientific notation.
So will it be like questions on the test where we have to turn that number into scientific notation without a calculator?
Yeah, you gotta submit in scientific notation, regardless if you got a calculator or not. So, and typically you can't do that. I mean, you can't do this. I mean, you could do it in your head. You could, but it might take you the whole class period. Right? How do you do what? Mode. You don't see a button say mode? And then mode, hit the mode. You see mode? Then what do you see? A bunch of words come up on the screen? It should be one that says science, normal, and engineering. Put it on science.
Push this one.
So now whenever you do your calculation, it's going to give you your answer in scientific notation. Let's see. 9.6 something. 9.65 times 10 to the 5?
So we was,
I don't know what the answer is.
oh no,
Yeah.
I need to know this.
No. Y'all don't understand what I'm saying to you. Y'all don't understand. I don't know the answers here. I know when answers are wrong. I don't know correct answers. I know when they are wrong, though. This is this is not A, B, C, D, E, F, G, multiple choice. This is science class. Okay? So that's why I just said, you understand what I'm saying, sir? I'm talking to you. I'm looking at you. Okay. So what I just said to you is we all have to agree. That's the only. I'm gonna just wait until you finish. I'm gonna just wait until y'all finish. So we have to all agree. That way, all of us can have the confidence that we are doing it correctly. If one person is getting one answer here, the other person is getting another answer, then we have a disagreement. Then that means we have to step back and we have to figure out who's right and who's wrong. That's what I mean. That's all I mean.
I'm gonna take a shot at it.
Huh?
I'm gonna take a shot at it.
You gonna do what?
Take a shot
Okay. Take a shot at it. Go ahead. Hold on. She already gave me an answer. Hold on. 9.6. What was it?
9.65606.4.
Wait, no. Give it a scientific.
That's what
That is the scientific.
Give it to me again.
9.656064, and it says E. So I'm assuming that's the exponent of 5.
Yes.
Okay. 9.6 to e to the 5.
Wow.
That's it.
Okay, that's
Somebody else get a different number.
I got that.
Okay. So then we have a 95% confidence that that is correct.
Yes.
Okay. Thank y'all. Have a nice weekend.
Are you gonna put some of the slides?
Yeah, definitely. I'm gonna put all of it on the Canvas page.
Okay. Were there any updates on the technical working?
No, not from the. I mean, I think it's a university problem. You know what I'm saying? You have you gotten any of your mastering? I think it's something with the network. All right, man. Good. Yeah.